Hi, welcome back. This is Professor Ridge. Today's lesson 7.8, the complex numbers. So basically we're going to start off with reviewing some things about square roots. We know that if we did negative 4 up until now, we would say that's not real. And the reason we didn't, or you could say undefined, but a lot of times we'd say not real because that kind of begs the question, well, is there something that's, if it's not real, what is it? And the reason we say that is because we can actually define, so it's not real because, let me go back to this, since there's no real number, so since what squared is negative 4, and the thing is there's not any number, right? There's no real number. So what we say is, okay, we can start there and we can make something up. So we're going to define square root of negative 1, which is not real, but we can make it something fake, something imaginary. So we're going to define that to be the imaginary unit. Okay, so this is where we start for complex numbers. We're going to define the square root of negative 1 to be I, which is the imaginary unit. Okay, and then from there, and also, if you square both sides, I squared is going to be negative 1. So by definition, square root of negative 1 is I, and I squared is negative 1. Okay, so we start there, and we build this imaginary number system. And then one more definition. We're going to define the square root of a negative number is equal to the square root of negative 1 times the square root of p. Okay, so we're going to, p is greater than or equal to 0. It's a positive number. Okay? So now we have that in our way, we can express, instead of saying square root of negative 24 is not real or undefined, we've defined it now. So let's try a couple of examples. Okay, let's look at exercise 10, square root of negative 9. So whenever you have a negative number, you factor out the square root of negative 1, and we know that's by definition I, and the square root of 9 is 3, so it's just 3i. I times 3 and 3 times I, it's the same thing. It looks nicer, right? 3 first, then the I. Okay, square root of negative 12, so number 14. So again, we pull out the negative 1, which is the I. So that's I. Square root of 12 is 2 times 2 times 3. So 2 comes out. And me personally, I like to put it out in front of the I. So it's 2i square root of 3. But it's also acceptable to put the I at the end. So 2 square root of 3i. Now, me personally, I don't like this way because if you wrote that square root a little bit longer and the I was under the square root, that means something different. So you got to be careful. Okay, the I is outside. So note, square root of 5i is not equal to square root of 5i. Right? Those are different. So I don't want to get confused with the I being under the square root or not. Okay, so just be careful. How about number 20? You got negative square root of negative 75. So again, I'm going to factor out the square root of negative 1, which is I. Now minus a square root of negative 1 is not, those negatives don't cancel each other. This is negative I. or minus I, either way. Square root of 75 is 3 times 5 times 5, so 5 comes out. So it'll be negative 5I square root of 3. And again, you can write the I, and I prefer to put it in the middle there. Okay, so either way. But again, I prefer this one, personally. So imaginary numbers is any number that can be written in the form of a plus bi, where a and b are real numbers and b cannot be 0. So if b was 0, then it would just be a regular, it would be a real number. So example of imaginary numbers, you might have like 3 plus 5i, or you could have square root of 2 plus 4i square root of 7. Those are imaginary numbers. What makes it imaginary is the I part, the square root of negative 1. Now you take away the union of all your real numbers plus all the imaginary numbers. We call that the complex number system. So complex numbers, and then all you have to do to get the union between all the real numbers and all the imaginary numbers is take away this last portion where b can't be 0, because then the I part will go away and then it's just a real number. That's what you have left. Okay, so complex numbers are real numbers, imaginary numbers, they're the union of both sets. They're everything now. Okay, so again, just compare the definition: complex numbers, imaginary numbers. The only difference is you take away the condition that b cannot be 0. So if b was 0, then you would get something like 5 square root of 2 plus 0i, which is just 5 square root of 2, which is a real number. Or simply, if you had 3 plus 0i, well, that's just 3. See, that's a real number. So a real number is a complex number. An imaginary number is a complex number. So imaginary number could be 5 plus 3i. Okay, so imaginary numbers are complex numbers. Real numbers are complex numbers. So complex numbers covers everything. Alright, so now that we established the complex numbers as a number system, we need to make sure we know how to add them, subtract them, multiply them, divide them, simplify them, all that stuff. So let's try how to add them. Number 28, 5 minus 6i plus 8 plus 9i. Now normally what I tell my students is if those were x's, not i's, and you just thought of it as an algebraic expression, how would you simplify this? And most people right away, without thinking very hard, say, oh, you just combine like terms. So 5 plus 8 is 13. Negative 6x plus 9x would be positive 3x. And then my reply is, yeah, that's exactly what you do. Just for, even though I is not a variable, it's something very specific. It's the imaginary unit, square root of negative 1. But if you just pretend that it was a variable and combine like terms, that's exactly how you would add two complex numbers. Okay, no different. So it's just like combining like terms. So for 30, how would you subtract them? And again, if those were x's, not i's, you would tell me, okay, first distribute that minus sign. And then combine like terms. And that's precisely what you would do with complex numbers. Okay, so good. Let's look at 36 here. Now again, if these were x's, if you did 3x times 9x, what would you get? You would go 3 times 9, because you could switch the order. That would be 27. X times x is x squared. So you get 27x squared. So any ideas about 3i times 9i? And then most time out here, okay, 27i squared, which is exactly right. But then we got to remember, oh yeah, I squared I squared is equal to negative 1 by definition. So we got to do 27 times negative 1, which gets us negative 27. Okay? So that's where I would deviate if it was a variable. I is something specific. So I squared is defined to be negative 1. Alright, and then the next difference here, you cannot multiply square roots that are negative by definition. Okay, so our way around it is we define that we can, if we have a negative square root, we got to pull out the negative 1 part of it, which is the I. And normally I skip that. I just go straight to I square root of 49 times I square root of 16, which is 7I times 4I, which is 28I squared, which is negative 28, because I squared is negative 1. Ken, you don't have to show all that work. You can go straight to here. Okay, but you remember, always, always, always pull out, meaning factor out, first before you do anything else. Okay, you can't do any proceed until you've made all the square roots positive, so you got to factor out the negative. Because if we didn't do that first and we multiplied negative 49 times negative 16, that would be a positive number, and then we'd get the wrong answer. We'd get positive 28 instead of negative 28 in this case. Okay, so always pull out that negative first before you do anything. Let's try one more of those. Square root of negative 15 times square root of 10, so that's going to be I square root of 15, I square root of 10, which is I squared square root of 15 times 10. I'm going to factor I squared is negative 1, 15 is 3 times 5, 10 is 5 times 2, so 5 comes out, times the negative 1, so it's negative 5 square root of negative 6. Alright, so now let's look on to the next one that's a little different, 46, 2I times 7 plus 3I. And again, I would remind my students, if those were x's, not i's, what would you do? What would you do with something that was like 2x times 7 plus 3x? And I'd have plenty of students saying, oh, just distribute the 2x, and you get 14x plus 6x squared. And that's precisely what you would do with these two imaginary numbers. You would distribute the 2i, get 14i plus 6i squared, but then you got to remember the I squared is 6 times negative 1, which is negative 6. So I got negative 6 plus 14i, which is my a plus bi form. So you put the negative 6 in front. Okay? And then how would you do 52? You have a binomial times a binomial. I mean, it's still imaginary number times imaginary number. But if I were to say, okay, if those were x's, what would you do? Most people say, oh, you would distribute FOIL. So you're going to do the first terms. So it's negative 12 plus 16i. Then you're going to take the 5i and distribute it. And that's going to be plus 15i minus 20i squared. And then you got to remember this is equal to negative 20 times negative 1. So it's negative 12 plus 31i plus 20. And then combine your like terms, 8 plus 31i. So that's your a plus bi form. Okay? If we have 3 plus 2i squared, we're going to use the square formula. Square the first term plus 2 times the first term times the second term, so 2 times 3 times 2i, that's 6, 12i, plus 2i squared, 2i times 2i, that's 4i squared. So again, that's going to give us negative 4. So negative 4 plus 9 will give us 5 plus 12i. And then just like we had the conjugate with the this is for the next page. If we did a conjugate, a plus bi times a minus bi, these are called conjugates. Just like we did with square roots. And you multiply them. This gives you our different squares. It's going to be a squared minus bi squared, which is a squared minus b squared I squared. But the I squared, the minus I squared minus b squared I squared is going to become a squared plus b squared, because the I squared is negative 1. Negative 1 times negative b squared is positive b squared. So then we just learned the shortcut. It's going to be a squared plus b squared. Okay, so for 68, so you got to remember when we're simplifying this, put in a plus bi form. It's the square root of I is the square root of negative 1. It's like a radical. So we're not, to simplify this, we want to do the conjugate. So we just change that middle sign. And I just showed you the shortcut on the other side. You're going to, on the bottom, if you take a number times its conjugate, you're just going to square the first number. Minus 3i times 3i becomes minus 9i squared, which becomes plus 9. And then on the top, we got to FOIL, or distribute the 4, so that's going to be 8 plus 12i. So we get 8 plus 12i over 13. And then you're going to split it up, so it's a plus bi. It's going to be 8 thirteenths plus 12 thirteenths I. And that's a plus bi. And then reduce the fractions if you can. Alright, let's try one more of those. I over 4 plus 2i. So we're going to multiply it by the conjugate, 4 minus 2i. So on the top we distribute. We get 12i minus 6i squared. The bottom, we do the shortcut. It would be 16 plus 4. So we get, remember this is going to be positive 6. So it'll be 6 plus 12i. Bottom's 20. We split it up. 6 20ths plus 12 20ths I, and then reduce those fractions. 3 tenths and, let's see, 4 goes out of those, so it'll be 3/5 I. Now, on this one, I would just multiply the bottom by I instead of 3i. I mean, you could do 3i, or minus 3i is technically the conjugate. But since the only thing that I need to worry about is that I can just multiply by I over I. So I'm going to get 6i squared plus 3i over 3i squared, which will get me negative 3 on the bottom. negative 6. Now split it up, negative 6 over negative 3, plus 3 over negative 3. So it'll be 2 plus, 2 minus 1i, which is 2 minus I. Alright, let's try number 82. 5 minus 2i over 3 plus 6i, multiply by the conjugate of the bottom. So just change that middle sign. And we're going to distribute everything. Well, the bottom's easy. We're going to square a, so that's 9, plus square b, 36. And it's plus because the I squared changes the sign. Okay, the top we FOIL. So we get 15 minus 30i minus 6i plus 12i squared, which will give us 45 on the bottom. On the top, remember, this is going to be negative 12 plus the 15 in front, that's 3, minus 36i. Split it up into two fractions. So 3 over 45 minus 36 over 45i. Reduce either of those fractions or both, if you can do both. So that's 1/15, and let's see, 6, no, 9 goes into both of those. So 4/5 I. And there you go. Okay, and then the last thing in this section is how do you reduce powers of I. So if we know that I to the 0 equals 1, I to the first equals I squared by definition is negative 1, I cubed is I squared times I, which is negative 1 times I, which is negative I to the fourth is I squared squared, which is negative 1 squared, which is just 1. I to the fifth is I squared. Now what I do is I'm going to go 5 divided by 2 is 2, remainder 1. So it's negative 1 squared times I, which is just I. And there's a pattern here. But the way that I'm going to have you do it is just take I to the 32nd. That's going to be equal to I squared. You're going to go 32 divided by 2 is 16, remainder 0. Right, which is just negative 1 to the 16, which is just 1. If I do I to the 57, I squared, now you're going to go 57 divided by 2 is 28.5, so that's 28, remainder 1. So it's 28, remainder 1. So that's going to be negative 1 to the 28i, which is negative 1 to an even power is positive 1, so that goes away, and then the I is left over. So I to the 103 will be I squared. 103 divided by 2 is 51.5. Just double check that. Yep. So 51 remainder 1. So there's the 51 remainder 1. So that's negative 1 to an odd power, which is negative 1. So it's negative I. I did I to the 486. that's equal to I squared to the, so I'm going to go 486 divided by 2 is 243, remainder 0. So the remainder 0 part, it's I the 0, which I don't have to worry about. So just, that goes away. And then it's negative 1 to the odd power, which is negative 1. Okay, so that's how you do it. Divide by 2. That power will tell you if it's negative or positive, and then if you have a remainder 1, then it's negative I or positive I. If you have 0 remainder, the answer would be 1 or negative 1. Okay, so that's the way I do it. Alright, so that concludes lesson 7.8. Go to My Math Lab and complete your exercises there.